Okay, I'm ready. I'm Katja. I've been a web developer for 15 years. I mostly work with charities and grassroots organizations to help them get the most out of tech. I got interested in functional about in 2014. I saw a talk on F#, and at the time I was a PHP and JavaScript developer. So F# on .NET didn't really make sense for me. I couldn't use it at work. But then a couple of years later, when the JavaScript ecosystems were really creaking around 2015-16, I got introduced to Elm. And as a kid, I was like really terrible at numeracy. But then when I got to algebra, that really clicked. And so I think that something about my brain likes this algebraic like composability. And Elm, with the added benefit of strict static typing, it like totally made sense for me. I haven't looked back since then. And I've been an active member of the international functional and Elm community ever since then as well. So functional programming is a massive topic, and I'm not planning to teach it to you. But what I will do is give you a brief history and some tools and vocabulary to help you get started if you want to explore functional ideas. And I'm going to try and use like plain language. So I might say things that aren't like strictly true in a mathematical sense, but that's okay because I'm not trying to teach maths. My intention is to give you access to ideas and not to make you a master of functional programming. And by the end, I hope that you'll start to recognize where you're already using functional and where you're making a choice to use it or not to use it. And ultimately, I want this talk to inspire you to have a go by demonstrating some of the benefits of functional thinking. So, the history, it all started back in 1920 with lambda calculus. And at the same time, there was another theory being developed called combinatory logic. And obviously computers weren't that big of a thing in the 20s and 30s, but you've probably heard of Alan Turing and his Turing machine. And that also was based on these functional paradigms. He basically proved that you could apply lambda calculus into computing. So in the 50s and 60s, when computing was a much more of a thing, there was a language developed by John McCarthy called Lisp, which basically means list processing, I think. And there was also at the same time, IPL and APL were developed as functional languages. But most of the languages at the time were procedural languages, like you probably heard of Fortran and COBOL, and then like a bit later on, BASIC and C and Pascal. They're all examples of procedural languages. And they differ from functional languages because those procedural languages are imperative languages where the programmer tells the computer the steps to do by using blocks or goto to control the flow of the program. And it's really hard for a human brain to follow. These get very complicated very fast. And the programmer in imperative languages also has to make direct commands to the execution environment, like modifying memory registers. So you have to know like what your machine is running on and things like that. Functional is a totally different paradigm, which is declarative programming. It's a declarative style of programming where the programmer writes what to do, not how to do it. And that means that you can think more like a human being rather than trying to think like a computer. So in the 1970s, there was a bit of a boom of functional. So people started moving away from these imperative languages and thought, oh, functional might be a good idea after all. But then in 1980, or in the 80s, objects appeared with the advent of Smalltalk. And the industry, mostly since then, has basically resisted functional paradigms as being impractical in production. And we'll see why in a minute. But in basically like recently, so from the 90s through the 2000s and up to now, it has been gradually coming back into the mainstream, and many object-oriented languages are actually adding features into themselves to make it easier to use them in a functional way. That may or may not be wise. We'll also touch on that in a minute. So When you first start looking into functional, you'll find that most of the things you come up against are written by like mostly male, mostly white people with a mathematical background. And that means that it's like not really that accessible to the majority of the demographic of human beings. So I've put a bunch of words on the screen for you here so that you can safely ignore them when you're starting out with your functional quest. I am going to use some of them in this talk, but you don't need to understand all of these words. What you need to do is just start doing functional. Non-academics like doing computer science as a norm is comparatively new. Like it's only happened in the past 20 years, right? Before that, it was all academics doing computer science. And now it's just like everybody, really. In his talk, Evan Czaplicki, who's the creator of Elm, which is that functional programming language that I mentioned earlier that compiles to JavaScript, he talks about that you don't have to understand group theory in order to be able to add things together. So, for example, if you have 2 apples and I give you another one, you know you've got 3 apples. You're using addition, but you don't understand necessarily what makes addition possible, what makes addition reliable. And the same thing applies to functional programming. You don't need to understand these words. You just need to be able to start doing stuff, and you'll gradually start to understand the concepts before you can talk about them, and that's okay. And you might never even want to talk about them or need to talk about them, and that's okay too. So one example of that you probably are using is a lexical closure, which in JavaScript was the first language to bring it to the mainstream. It was invented as part of the Scheme framework, or the Scheme language, which is a Lisp-based language. It basically just means that functions that are inside functions have access to the variables in their wrapping function. And it's called a lexical closure, but you don't have to know that. So if you want to get started with functional, you know that there must be some principles that underpin the functional paradigm, or what it means to be functional. So you do a quick Google, and again, totally unhelpful. These 3 principles that make functional programming possible are not very transparent to see what they are. But that's okay. That's why I'm here. I'm going to tell you what 3 things make functional programming possible. They are immutable values, values that can't change once they're created. Pure functions. So these are functions that don't have side effects, which I'll get into in a bit more detail later. And the ability to string together these pure functions and immutable values, and impure functions as well. And these are called higher order and first class functions, which you'll hear a lot when you start to look into functional. But they're basically just assignable, passable, returnable functions. And you're probably already using them. You just don't necessarily realize it. So functional programming is just a set of tools, these 3 tools, essentially, and the skills of knowing how to use them. And you don't even have to use a functional language. Most modern languages have built in to their core the tools that you need to start these 3 tools. So great. Is it really that simple? Pure functions, that means no side effects. So like in a strictly mathematical sense, the calculation will always be the same. If you give it the same inputs and the same outputs, you will get the same answer. Sorry, the same inputs, you'll get the same outputs, which means that you can memorize that value, that output value. You know that it's always going to be the same. So you don't have to run that calculation over and over again if you're getting the same inputs. And that might sound similar to caching that you're familiar with. But with caching, you probably know it's difficult because you always have to check if you've got the most up to date. And that's because of side effects. That's because we're working with things that are outside of our program. So basically, academics thought it would be a great idea to remove side effects. which means that you don't even need to have a shared state. You don't even need to know what the state of the world is. And that's great for proofs, but in practice, what it means is that nothing can change, right? And there's no such thing as time, and you can't use random, and there's no input or output. So you can't see anything on your screen, and you can't put anything into your program from the keyboard, for example. You can't have a database. So all of these things, obviously, it's not practical to go pure functional. And without the help of a functional language, it actually takes quite a lot of discipline. So in modern JavaScript, you can do pure functional. You can not use assignments, just use consts. So don't use var and let. Don't use loops, use recursion instead. And use object literals with spread syntax and array literals, which are both immutable. So no mutatable objects. But if you do try and do this in a non-functional language, and you're trying to learn functional, it will probably feel like you're fighting against it rather than it's helping you. Like maybe you've tried a partial typing system, like putting a TypeScript file into your JavaScript program, and you basically, it becomes very apparent very quickly that you don't get the benefits unless you're like 100% typed or 100% functional. Because if you sometimes, like it's difficult doing functional, and sometimes you'll find it would just be much easier if I could just mutate this object. And if you just use one mutable bit of data in your program, then your whole program becomes unpredictable and not functional. So it's basically too tempting to do that sometimes. So let's not worry about what functional means or like where it came from or anything. Let's just try and find out what are the things that I can do to become more functional or to learn functional paradigm. These 5 steps are defined by Eric Normand, who's a Clojure programmer who does a lot of training and teaching. He kind of bridges the academics into industry. And what he proposes is that in order to be a functional programmer, you have to master these 5 different skills. And the one at the bottom of the hill is the easiest. So just identifying what the different parts of your code are, what type of thing they are, and then being able to use higher order functions, mutable data, modeling data, and finally architecture, which is like the biggest, hardest problem that you probably need the most experience to look at. So I'm going to go through these now, one at a time, and explain what they mean. So the first one is being able to identify the parts of your program that are data, calculations, or actions. And the easiest one is data. Data is your immutable values, your values that can't change once they get created. They look like this. The top example is JavaScript and then Elm underneath. And with all of these examples, I do like one JavaScript and one Elm underneath. These are basically always there, never changes. You can go back and look it up. You can look at it whenever you want to and interpret it throughout your program however you want to. These are your like datas, right? Easy. You need to be able to identify calculations. So calculations are your functions without side effects. They're your pure functions. They're the functions that when you put something into them, it always gives you the same result. And calculations don't just have to be numbers. You can calculate any kind of data. The only rule is that if you put something in, you always get the same result with the same input. So those also are easy. Actions is where it starts to get a little bit tricky. Actions are functions with side effects. So these are functions that either affect or are affected by the outside world. These are functions that it matters when they happen and it matters how many times they happen. The context that they're in, that matters. So these are the functions that you want to identify in your code and spend a lot of time on them. And if inside your action function, there is some logic that does a calculation, move that calculation code out of your action function into its own pure function so that you can only concentrate on the action part of the action function, isolate everything else. So one easy way to spot action functions is if it like prints something. So console log obviously prints something to your screen, which means that if you run it 3 times, it'll print it 3 times. So it matters how many times you run it. Another thing would be, does it rely on outside information? So does it rely on time? Does it rely on, so this example is sending an email. And if I send the email today, john@example.com might get it, but then tomorrow he might delete his email address. If I send it tomorrow, he won't get it anymore. So it relies on something that is outside of this system, and that is what makes it impure. So that's the first easy step. That was identifying actions, calculations, and data within your program so that you can start to separate them out. So you can start to think about them as different types of things in your program. The next stage of becoming functional is really understanding how to use and create higher order and first class functions. So remember, these are the functions, like the first class functions are functions that can be assigned to variables, passed as arguments, or returned from functions. And higher order functions are functions that take those first class functions as arguments or return them. And these functions that I'm talking about, they can be actions or calculations. They can even be anonymous. They don't need to be named or assigned to a variable, but you need to know and understand how to sort of harness the power of them. One of the great powers of this is partially applied functions, which basically is built into functional languages, but not in JavaScript. So in JavaScript, that curry to helper function is a function that makes this partial application possible. And basically all it means is that, I'll put the Elm one up as well. The exaggerate function is a function that takes an integer and another integer and returns an integer at the end. And in a functional language, the way that that happens is it applies the function exaggerate onto that first integer first. That returns a function that needs an integer to return an integer. And so these are like really powerful, tiny building blocks of functions that you can then reuse in like other parts of your code for loads of different things by just like stacking them, composing them up together like this. And you probably will be using higher order functions like mapping and filtering, where you're putting a function inside another function and returning things. So you probably use this already without thinking about it. The next difficult thing that you have to do is learn how to work with immutable data. And immutable data is something that we have to force ourselves to do because computers, like computer memory, is designed to be mutable. So working with immutable data, that is all on us. So that's on us for either our teams that have to enforce it or our language that we're using has to enforce it. And the main skill is learning patterns of how to design your data for easy and reliable copying. So there are 2 key principles here. One of them is transformation pipelines with things like map and filter, which you probably already use, where you start with some data, you run it through a series of transformations, and then you get the shape of the thing that you want out the other end. So for example, if you have a list of strings, you can run them through a function that strips all the spaces out, then run the result of that through a function that makes them all uppercase, then run the result of that through a filter for some whitelisted values that you have somewhere that are all uppercase values of words without spaces. And so you build up like that. And the other thing, which is slightly more complicated to understand, is how your language or framework wants you to update nested data, so like nested records. This is from the Redux docs. And the correct way to update this nested field forth is to take the state of the outer one and copy it to a new object, take the state of the second one all the way through like that. But what you might be tempted to do in JavaScript is this second example, which is a mutation. You're mutating that nested state object and just adding the data onto that action. And that's not what you want to be doing, because now you've introduced immutable value into your program, which makes it unpredictable. So in Redux, what they have is a set of like magic functions that allow you to use a better pattern without having to explicitly write it all out, like the top one. And this example is called a create reducer. So what you want to be learning is how your language or framework wants you to update nested data. So how it wants you to handle working with all of these large immutable data objects. Now, the fourth thing, there's one more after this one. The fourth thing is learning how to model data. So there's two kinds of data that you're going to be modeling. There is API data for the outside world to consume, like this. So maybe you're publishing a list of people, how old they are, and what pets they have, so that someone can display it in their website. And this is like a really good readable way for the people using that API to be able to use the information, use the data that you're giving them. But internally, your data structures for this same data probably want to be different to make your program more efficient, to make it easy to reason about, to enforce making impossible states impossible. So, for example, if in your world, in your domain, people are only allowed to have one or no dogs, then a really safe way to model that would be dog is either true or false. And that means that you can never get into the impossible state of someone having two dogs. But the person who's consuming your API doesn't need to know that or see that or think about that. But you, when you're writing the program, does need to know that and be very conscious of it. And so these three different ways to model the same data are part of becoming a functional programmer, understanding that you take these bits of data and you pass them through these transformations so that the thing that you're trying to do at the time, the data makes the most sense for that thing. And the final functional thing that you want to learn and focus on is architectural patterns. So these two patterns are common functional patterns. The one on the left is the Elm architecture, which is also what the Redux state machine uses. And with this one, you basically have your shared state, which is your model at the top. And that state gets fed into a view function, and the view displays the data on the screen, or displays the state of your application, the state on the screen. And that view, a user has an opportunity to interact with that view, right? They can see it. That view can react to time. It can react to anything that happens in the outside world. So that's like your portal to the outside. If something happens that the view needs to respond to, it will send a message through to an update function. And that update function knows what needs to happen to your data if that update happens. So it knows how to transform your data into a state that represents what should have, what the world should look like after that action happens. And that updates your model. And when your model gets updated, it sends a message to your view to re-render itself. And in the other pattern on this slide is the onion pattern, which is essentially the same thing. Like all these architectural patterns of functional are trying to protect your static data, your domain model from the outside world. They're trying to put as many buffers and control like what changes because of the unpredictability that is outside of this thing. So you have an API layer, which is your outside world messenger, which sends messages out of your program and receives messages in from the outside. And then your business rules, which can transform those messages, or they know how to like take a copy of your current domain model and what it needs to change into because of those messages. And that's essentially it. So why does all of this matter, right? Well, functional paradigms are designed to make things easier for humans. So it might be harder to write sometimes, but it's much easier to read and maintain. Once you've solved a problem, you don't have to solve it again. And it allows us to solve small parts of a big problem in isolation. So we nest them together, we chain them together, so we can use our limited brains to just reason about one small part of the problem and then shelve that off and be able to reuse it over and over again. And we can string those parts together reliably to build up complexity. So the computer will handle the hard part of how to do something. You don't have to spell out the steps, which obviously somebody like who's written the compiler will have spelled out those steps. The people who write your computer hardware need to know like different bits of how those translate into what the computer needs to know. But you, the programmer, doesn't need to know that. We don't have to write or read like complicated control flow or branching logic. I can guarantee that you've been lost in some if else, if else, if else, this happens. It's impossible for your brain to like follow what's going on there. All we have to do as functional programmers is define a series of states of being that we know we want our domain model to look like, and the functions that transform data into those states. And most of all, functional makes it super easy to test, and we can be really certain of the reliability of the overall program, which means that we don't have to be stressed when we're writing our code or refactoring our code. So hopefully I've convinced you to try some functional. Easy thing to start would be just start recognizing the patterns, like I said, or just start looking at your programs and separating out the things that are data, the things that are actions, and the things that are calculations. You can try just using immutable. Like don't let yourself use let or var, only use const, and see where that takes you. Try not to use any loops or branching logic, like see where all of it takes you. And you can definitely start separating your pure functions from those with side effects, because that has so many benefits and will reduce your stress levels so much. And if you want to dive into a language that forces you into a functional paradigm, then definitely go for it. So I've listed some languages here, and also some resources to really get started at the very beginning. The structure and interpretation of computer programs and monads and gonads are both ones that are a little bit more like if you're interested in the theoretical side of functional programming. But the other ones are more about if you just want to be a functional programmer. And that's it.